Welcome to AtliQo Bank. We're stepping into a real-world corporate data science role. Our objective is to take 50,000 rows of messy, raw lender data and extract a highly profitable credit card strategy. We will tackle this workflow in 3 distinct phases. First, we'll securely import the SQL database. Second, we'll clean the records using strict business logic. And third, we'll build an exploratory demographic dashboard to locate our target customer. Before we start querying, you will need your local environment set up. Make sure you have a Jupyter notebook ready, loaded with pandas for data manipulation, Seaborn for charting, and a MySQL connector to handle the database transfer. Anyone can run a statistical formula. A successful data scientist applies domain logic to raw numbers to uncover hidden, highly profitable target demographics. Step 1 is getting the data into our workspace. We will use the MySQL connector library in Python to establish a secure bridge between our local database and our Jupyter environment. Instead of exporting static CSV files, we write SQL read queries inside pandas. This pulls the massive customer and transaction tables directly into Python data frames. Once loaded, you must close the connection. Leaving pathways open consumes server memory, eventually causing a system crash. By cleanly extracting and validating this raw information, we've built the stable baseline required to begin our advanced analytical cleaning. When we run a basic summary function on our customer table, we spot a major gap in the dataset. We are missing the annual income records for exactly 50 customers. Filling those blanks with a global average means high-income earners heavily skew the math upward, assigning low-earning profiles artificially high salaries. Instead, the industry approach groups customers strictly by occupation, calculating a realistic median income for each exact job title. We then write a Lambda function to rapidly map these targeted median values across the entire dataset, replacing every null with the correct salary tier for that individual's profession. This contextual imputation preserves the true economic reality of our customer base. We avoid building a credit card launch strategy on inflated wealth metrics. Moving to the credit profiles, our filters reveal a logical impossibility. We have rows where a customer's reported outstanding debt mathematically exceeds their maximum assigned credit limit. The textbook instinct is to use standard deviation to isolate and delete these rows entirely, but dropping them means throwing away thousands of points of valuable transaction history. This chart displays the pragmatic business fix. We use row location functions in pandas to isolate the impossible debt values, and we manually cap them so they exactly match the customer's maximum credit limit ceiling. In corporate data science, adjusting data to align with strict business rules yields better results than chasing statistical purity. We keep the genuine user data, and we fix the systemic error. With a clean dataset, we are ready to find our target audience. First, we need to convert exact continuous customer ages into distinct, business-friendly categorical brackets, like youngsters and seniors. Instead of plotting individual charts one by one, we use a Python loop and subplot matrices to efficiently generate a comprehensive 2x2 dashboard, comparing payment methods and e-commerce platform usage. This dashboard highlights transaction volume across age groups. Older demographics, those 26 to 65, already rely heavily on traditional credit cards for daily spending. By contrast, isolating the youngest bracket reveals completely different habits, showing an overwhelming preference for digital wallets and online apparel platforms. They spend heavily online, but rarely use traditional credit cards. That specific combination of high digital volume and low existing credit usage identifies the 18 to 25 demographic as a highly profitable, untapped market. We took disorganized vendor records, applied contextual cleaning, and built a data-backed product strategy. AtliQo's new credit card will be explicitly designed and marketed for the 18 to 25 demographic. But identifying the target market is only half the process. In Phase 2, we have to prove mathematically that our proposed card features will actually succeed in a real-world trial run. Finding the audience sets the direction. Executing rigorous hypothesis testing provides the undeniable proof we need to secure executive approval for the launch.